Welcome back, ladies and gentlemen. This is the third video for atomic periodic trends. So this handout you should have in front of you. This is going over the trends again, just in case you missed some points on the video. And there are multiple ways of explaining how these trends work. Just understand the major concept and how to compare if two elements, which one will have a bigger radius, higher or lower ionization energy, and electronegativity. So have this paper in front of you. If you don't, pause it and continue a little bit. Okay. The first trend is the radius. As we referring from the notes we did in the last video, the trend going to left to right, it gets smaller going left to right, and it's larger down, it's increase. Okay, smaller, which is decrease, going to left to right here. Please fill this out along with me. Okay, so so it gets left to right, smaller. At the bottom, it increase. And we already know smaller, decrease, decrease left to right. Because protons are added to nucleus. So the pull, the attraction is higher. Okay, add that on. So the pull proton is added. P plus is proton. And then going down, so this is going left to right here. Left to right. Going down, increase because not elements, energy level added. Level, or just our rings are added as we go down each row. Rings added, so as rings are added, the atom gets larger. Okay. A cation is positive, an anion is negative. Okay. Cations are, so remember, it's positive because it lost electrons. And anions are negative because it gained electrons. If it loses electrons, it's going to be smaller. Cation is going to be smaller. Well, it's going to be smaller. And if it gains an electron, if it gains one or more electron, it's going to be larger because we're increasing the electron cloud. Okay. So there's reasoning there. So rank these following from largest to smallest. Now you will need a periodic table for this. So we look at this. Here's a nice handy dandy periodic table. We look at three elements. Lithium. Let me show both. Okay. Hope it fits on the screen there. Lithium, carbon, and fluorine. Lithium is right here. Carbon is right there. And what? Fluorine. Okay. So if you think about it, they are all on row 2, correct? From left to right, it's smaller, so which one's the smallest? It's going to be, so larger to smaller, it's going to be the smallest. Fluorine's the smallest over here. So fluorine, carbon, and then lithium. That's how you would do that. Lithium, carbon, fluorine, carbon, lithium. And then the next one, Li, Na, K. Li is here, Na is here, K is there. As we go down, what happens to the atom? As we go down, the atom gets bigger because we're adding energy levels. So then the smallest one would be the same order. Li, Na, K. Okay. Yeah, so I don't have to do all the difficult, easy ones. Let's go to the last one. GaClAl. GaCl and Al. Okay. So we look at the number of rings first. Okay. Ga here is on 4, level 4. It's got 4 rings. Can't deny that. It's got 4 rings. So Ga is going to be the biggest. And then Al and Cl, they're on the same row, so they both have 3 rings. But which one will have more protons pulling? Chlorine will have more protons pulling, so chlorine is going to be the smallest one. Chlorine, Al, and Ga. That's how you do that. Chlorine, Al, and Ga. Right. And then match the larger pair. Circle the larger ion. Remember, if it's positive, then it'll be smaller. So this is positive. So the regular one is smaller. I'm sorry, smaller. I need to circle the larger one. So the larger one is the one that is normal there. Okay. Cations are smaller, so the positive ones are smaller. The negative ones are bigger than the original. Okay. The negative one's bigger than the original. The positive one's smaller, so the original is bigger than the bigger than the positive one. Stuttering there. Sorry about that. So as we go down, here you go. We go down. We can see another visualization here. All right. And an analogy to this, one way to help you understand this is here. This thing we call the size equals snowman. Okay. If you know how to draw a snowman, the idea is really good. But this is not your reasoning though. This is just to help you remember. So don't ever use snowman as a reason for anything. So the snowman, if let's say I build a snowman like that. All right, snowman's gonna be fatter. The belly gets bigger as we go down. All right, snowman. So it looks like a snowman. And then bully comes over. A bully, not very friendly bully, of course. Bullies are never friendly anyways. Comes over, knocks down my snowman. The snowman falls. And then yeah, there you have your trend for your size. The size, the S for snowman, the size for snowman. So left to right, it gets smaller. Right? You can see by the bottom, the belly, and the head of the snowman, it fell over. And so that's one way to remember the size. Think about the snowman. And it's getting knocked over. That's your trend going down. That's your trend going left to right. Okay. Okay, ionization energy, the next trend. The energy required to remove an electron from an atom. So going to left to right. Remember, it gets smaller, so it's harder to remove. Okay? Smaller requires more energy, requires higher ionization energy. Okay? Smaller requires higher ionization energy. So it's harder to remove. Because they're smaller, they hold on to their electrons a lot closer and a lot tighter. So it's the opposite. So from left to right, ionization energy increase. It requires more energy to remove because they're smaller, they hold on to it tight. So smaller, why? Smaller atoms hold on to electrons stronger because they're closer. So electrons are closer. So electrons are closer to a nucleus. So it requires more energy, requires higher energy. I'm just going to abbreviate some stuff here. I hope you can read my writing. If you can't, just go back and listen to what I say and write down what I say. Thank you. Going top to bottom. Top to bottom here. Atom gets bigger. Remember, atom gets bigger. So larger atoms, going top to bottom, energy decrease. Because it's easier. It's further away now. It's easier to decrease. So you write that in there. I'm not writing that. That's a small box. So going top to bottom, the atom gets bigger. So I'll write some stuff. Larger atom, lower energy to remove because they're far, they're easier to snatch. They're not held onto as tightly by the nucleus because they're so far. Okay? So back to the periodic table. Don't draw a mess on your periodic table like I do. This is just for your example. Let me see if I can still use the same one. I'll just use a different colored highlighter to show you these things. So get that ready here. Nice periodic table there. Alright, this element, MgSiS. So ionization, MgSiS. Mg, right there. Si, right there. And then S. Okay. As we go left to right, remember, ionization energy increase. Ionization, IE, increase. So the lowest is going to be magnesium. It's on the same row. It's easy. Magnesium, silicon, and sulfur. Same order. Mg, Si, S. Cool. Good. That was easy. Cone. C-O, 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 and N-E. Again, look at that. I should have made this more difficult. So left to right, ionization energy increase. So then C, O-N-E. Same. Let's try this. Likna. L-I-K-N-A. L-I-K-N-N-A. Okay, 3 of those. So as we go down, it's lower ionization. So lowest stay down here. This is the lowest at the bottom. So the lowest is K, Na, and then Li. Okay? Complete number 3. Any one that I miss, I skip. That's for you to practice. Okay? That's for you to practice. And then I will post all these answers, the completed one, in the future on a future date to make sure that you have the correct answers. Okay? Circle atom on each pair that has a greater ionization energy. So we just compare these two, like Li or Br. So, Li or Br. Let me get a new clean periodic table here. Got a bunch of these to go around, but you don't. So don't draw a mess on yours. Just dot them so you can compare them. Li and Br. Li is right here. Br is right there. Li, Br. Which atom's bigger? You think about it. Which atom's bigger? So Br, because this one, think about the number of rings first. 2 rings versus 4 rings. Okay? So Br is bigger, so then it has a lower ionization energy. So Li has a higher ionization energy. Okay? Look at number 8. Number 8 here. Br and Cl. Cl, Br. Which one's bigger? Br. So which one's smaller? Cl. So the smaller one will have higher ionization energy. Okay? Pretty cool. Pretty easy. Do that. Complete this paper and move on to the back. To the back. To the back. One more thing. Last thing here. Electronegativity. The measure of the ability of an atom in a chemical compound to attract electrons. Okay? The trends are the same as ionization energy, because the smaller one, it's more attractive because it's closer to electrons that are floating around it. So left to right, electronegativity increase, electronegativity increase, because smaller atoms have nucleus. I don't know. There's so many ways to write this. I make a different definition each time, but it's still the same concept. Small atoms have nucleus closer to the outside, right? The surrounding, outside was surrounding, so attraction stronger. Okay. As we go down, remember it gets bigger. So then, guess what? The nucleus is smaller. So then, electronegativity decrease. As we go down, electronegativity decrease as we go down. So why? Larger atoms. Nucleus far away from the surrounding. The nucleus is too far because its own electron cloud is really big. So it's far away, so lower attraction. Lower attraction. Cool. Sorry, my handwriting is really ugly, so you just have to listen in and try to make sense of it. I can't fix that overnight. So rank the same concept here. Rank them in order. L, I, C, and N. Let's go L, I, C, and N. Right? These 3. So which one? So lowest, highest. So the biggest. So it says lowest to highest electronegativity. So you want the biggest atom to the smallest. The biggest atom is Li. So yeah, same order. Li, C, and N. Not very creative there. Sorry on my part. Then Mg, Ca, Ba. Mg. Number 2, Ca and Ba. So which one's the biggest atom? Ba. It's at the bottom, so it's biggest. So Ba is the lowest attraction. And Ca is the next. And Mg is the smallest atom, so it can attract electrons a little better. Okay? So do these the same way you did the other page there. Compare with your neighbors. And, oh, let me do 1 or 2 on the left here, on the right here. Let's pick 2. You pick. What number? Okay, number 5. Sounds good. Number 5. O or S? O and S. Which one is greater electronegativity means smaller atom? Smaller atom. Smaller atom is on top. Oh, it's got 2 rings, right? Level 2, 2 rings. Level 3, 3 rings. So O is smaller. So it's got, there you go, circle O. Do number 8? Okay, sounds good. Let's do number 8. S or Cl? S and Cl. This table's getting messy. Trying to get different color here. S there, Cl's there. S and Cl. Which one is smaller? Smaller one will have higher electronegativity. And Cl's to the right, it is smaller. Cl. Okay? And there you have it. Okay. So it says here snowman, ice cream cone. Get your table. It's nice here. Draw the snowman. Oh, that's really nice. So snowman equals size. As it goes down, it gets bigger, it falls over, it gets smaller left to right. So there's snowman. And then I want to talk to you about this other concept called the ice cream cone. Ice cream cone is ionization energy and electronegativity. Okay? And so ionization energy, think about ice cream cone looks like this. Oh, look at that. Nice ice cream cone there. Ice cream cone, okay? He gets it knocked over. Look at that. You get ice cream cone going this way, knocked over. I don't know why it's bigger knocked over, but it shouldn't be. Should have been the same size. Sorry. Ice cream cone looks like that. The top is bigger. Ionization energy. Bigger electronegativity because the atom is smaller. So it's opposite from the size. Okay? Going left to right, ionization energy increase, i.e. increase going this way. And electronegativity increase going this way as well, as opposed to size. Size gets smaller, smaller radius, and higher ionization and higher electronegativity. Okay. Well. Time is running out, and so I gotta go home. This ends at today. Have this ready, done. Don't glue this in. This is two-sided. You fold all these worksheets that's two-sided and put it in the pocket that you have. All right. I'll go over the worksheets next.